So this is a factorization problem in which if you do not look for common factors at first, you will have a slightly more difficult problem than if you were smart and if you looked for common factors first. But you can still solve it. But let's do it the smart way, okay? So the first thing you would have to do is look for common factors, right? In every factorization problem, the first step is always looking for common factors. So in this problem, well, I've got 7, which is multiplying x squared. I've got 21x, which, well, 21 is 7 times 3. And also I've got negative 70, which is 7 times 10. So I can at first factorize everything by 7. So I can collect 7, which is a common term to all of them. So 7 times x squared plus, what do I have to multiply to get by 7 to get 21x? Well, 3x, right? 3x times 7, 21. Now, negative 10 times 7, negative 70. And now we've reached a much simpler problem, because now we can solve the inside here and just multiply by 7. So let's now solve this much simpler problem, much simpler. Look what I have to factorize now compared to what I had to factorize before. Finding the product of those two numbers and looking for numbers which product would be 449, like 490, would be a burden. But now we're looking for numbers which product is negative 10 and sum is 3. Since this is, well, 1 here, right? So sum and product, if we multiply, we're looking for product negative 10 and sum 3. Alright, so product negative 10. So I can multiply 1 and 10. I can multiply 2 and 5. I can multiply 5 and 2, and I can multiply 10 and 1. Right? But now, since the product is negative, one of them is negative, but since the sum is positive, the positive number is larger. So since one of them has to be negative, if I take this second example here, and if 2 was negative, I would have a product which is negative 10, and I would have a sum which is 3. So I can split this problem, this smaller problem, into, okay, this is a subset of that problem. So x squared plus 5x minus 2x minus 10. Right, so I've rewritten the same problem, which is just this part of the original problem. At the end, we'll have to multiply by 7. But we have split into this problem, and if you notice, 5x minus 2x is 3x, so we have not changed anything so far. So it's still the same thing. Now, if we collect like terms, so I've got x squared plus 5x, my common factor here is just x, so I would have x plus 5. Now, both of those terms are both is negative, right? Both are negatives. So I can collect 2, which is the only thing that they have in common, negative 2, and then I would have to multiply negative 2 by x to get negative 2x. And I would have to multiply negative 2 by 5 to get negative 10. So not surprisingly, I've got numbers which have common factors here. And now, if I collect x plus 5, which is the term that I have in common in both of those, I will have left x take away 2. Alright, so this is the solution to factorizing this simpler problem. And then I can just multiply by 7 to get the original problem's result. So 7x plus 5 and x take away 2. So this is our final answer, right? Oftenly students forget to multiply the terms here by the original value, and they give this as the result, But remember, the problem that you're solving is actually 7 times that. If notice that if you don't factorize 7 here, you can still find the solution to your problem. It's just that your products are going to be much larger. You're going to have negative 490. So you're going to be exhausted by all the products that you can do. However, you will find the same thing at the end, and you'll factorize and arrive at the same result. So let's look for the way in which you should do less effort. There is no need for that extra effort. Alright, so that's a kind of a slightly more difficult example, but you can still factorize. Next, let's look at some problems in which, well, we won't have many common factors at once, and we'll have to look for a bit more difficult numbers.